So let's try to do some study checks. The first one, identify the solution, the solute in each of the following solutions. 2 grams of sugar and 100 grams and 100 ml of water. If we think about it, the definition of solute is the less amount component in a solution. So here the 2 grams are less than 100 ml, so this is a solute and that's the solvent. 60 ml of ethyl alcohol and 30 ml of methyl alcohol. So methyl alcohol will be the smallest, so it will be smaller, sorry, and it will be the solute. The ethyl alcohol will be the solvent. 55 ml of water and 1.50 grams of NaCl. Again, you have the NaCl will be the solute and the water will be the solvent. 200 ml of oxygen and 800 ml of nitrogen. The solute will be the oxygen and the nitrogen will be the solvent. And these are the answers. And let's do another study check. When solid LiCl is added to water, it dissolves because the Li ions are attracted to the, so this ion is positive, it will be attracted to the opposite charge, which is the oxygen of the water, which has a partially negative charge. Chlorine ion, which is a negative charge, are attracted to the hydrogen atom of the water, which has a slightly positive charge. And these are the answers. Let's do one more study check. Which of the following solutes will dissolve in water and why? So to determine if they will dissolve in water or not, we have to remember the rule. Polar dissolve in polar, non-polar dissolve in non-polar. Okay, so water is polar, so we have to figure out any components here that will be polar or will ionized. So Na2SO4, when you put it in water, this is a solid compound, and when you put it in water, sodium will be ionized into sodium positive, SO4 will be ionized into negative polyatomic molecule, and then it will dissolve in the water. Gasoline is one of the non-polar molecules like oil. They will not dissolve in water. Iodine, it's an ionic molecule and it will not dissolve in water. HCl, ionic molecule that will dissolve in water. The other topic that we will talk about now is electrolytes. What is an electrolyte? What are the electrolytes? Electrolytes basically are the solute that can, or the substance that can conduct electricity, because they will ionize into positive ions and negative ions, and then they will conduct electricity if they are dissolved in a polar molecule like the water, for example. So NaCl is considered electrolyte. So we have 3 types of electrolytes. We have a strong electrolyte, weak electrolyte. So strong, weak, and a non-electrolyte at all. So how do we differentiate between these, or what does it even mean? So strong electrolyte, the solute dissolved completely in the water, completely, 100% dissolving in the solvent. or water. Weak electrolyte, the weak electrolyte are those who partially dissolve, partially, like 50%. The non-electrolyte, those who doesn't dissolve at all, doesn't dissolve. How can we know if the solute will dissolve completely or not? We have to follow this. So any ionic compound, meaning any compound that will separate or ionize into positive and negative molecule like NaCl. So you can see here NaCl here dissociation in water to Na positive and Cl negative. And you can see here if we have two electrodes to conduct electricity attached to a lamp, and we put the electrodes in a salt solution, you will see the lamp will light a very strong light. This means it's a strong electrolyte because it's completely 100% dissociation happens in water. The weak electrolyte, so the same experiment, exact experiment, but with different solution. And here we're using the HF. And the HF, when it dissociate in water, it dissociate in H plus and F negative. But the thing is, as soon as they dissociate, they have the tendency to actually get back together to form HF again. So you can see here the two arrows here. Whenever you have an equation that has these two arrows, which we learned last time, that's called reversible reaction, then it means that the dissociation of this compound in water is partially, it's not totally. And what does it mean, partially? So you can see the strength of the electricity is so low comparing to this. See how bright this is? How dumb is that? So let's look here in the chemistry. Again, same electrode, same lamp, same container, same everything, but here we have HF instead of NaCl. You can see two colors or three components here. You can see positive one white circle, which represent the hydrogen ion, and then you can see green circle that represent the fluorine ion, and then you can see a whole molecule composed of two circles, one white, have green, which contain or means that we have HF. So you can see here that the solution actually have three types of molecules. It has hydrogen, it has fluorine ions, and it has the HF as a complete molecule. So we call this a weak electrolyte. Non-electrolyte, you can see the equation like this. So this is sucrose, and the sucrose is non-electrolyte, means it doesn't conduct electricity because it doesn't dissolve in water. So it doesn't dissolve in water. And now we can summarize the equations into three major equations. If you have a salt and you see this arrow, and then you see the salt is ionized into positive and negative, then you have a strong electrolyte. If you have if you have another molecule and you can see two arrows representing reversible, and then you can see the H here and the fluorine here. Okay, so, and it's reversible, so your sign here is reversible, it's weak electrolyte. And then if you have a component or a molecule like glucose, and then one arrow, but you see the same molecule again without any change. It means it didn't dissolve in water, and it means it's not conducting electricity or non-electrolyte. Okay, so those are your three main observations that you need to find out. So whenever a solid is added to water, actually the physical characteristics of the water change, and also the boiling point and the freezing point of the solution will change. The boiling point of the solution will increase by adding solute to the water, and will decrease, the freezing point will decrease when the solute is added to water. We have two examples here that we actually use in the winter here in US. So here, the first example is adding salt to an icy road. And we all know that we add salt so it can actually help us walk safely, dissolve the ice. And this happens because when you add the salt to the water, basically it allows the particles of soil to mix with the water, and then it lowers the freezing point of the ice. Then it goes down, and then by going down it dissolves the water. Another thing is adding ethylene glycol to the water. So adding ethylene glycol to the water in the cars basically increase the number of hydrogen bonds that form in the solution, and then it lowers the freezing point and raising the boiling point of the solution. So in the car, it doesn't freeze the water that the car need when the engine raise the temperature of the car. Those are some study checks. So complete each for strong electrolyte in water. So calcium chloride, is it strong? It says it's strong here, and they are asking you to complete the equation. What do you think the equation will be? Would be A, which means it's not electrolyte at all. Would be B, calcium chlorine. Would be C, calcium 2 chlorines. Think about it and look at the formula. Yeah, we have 2 chlorine here, which means we will have 2 chlorine here when they are ionized. Same thing with K3PO4. Would it be the same like B, or would it dissociate into 3K and 1 PO4, or K3P3O4? Remember, PO4 is considered a polyatomic molecule, so we cannot actually do the third one at all. They are connected. When they dissociate or ionize, they ionize together. So it will give us 3K and 1 KO4 when it's ionized. And these are the answers. Another study check. Which of the following reactions represent the dissociation of a strong electrolyte in water? So it's asking you about finding the one that basically dissociate 100% dissociation in water. So we need to look for two things. We need to look for the arrow to make sure we don't have reversible reaction, and we have to find out that we have molecules to the left and ions to the right, basically. So for example, B, we will exclude it at all, because if you look here, it's the same compound. So it means it's non-electrolyte, didn't dissolve. So it means it's non-electrolyte. Same thing with D. Look at the D, it's the same compound. So B and D both are non-electrolyte. So we now have A and C. A and C, we need to figure out which one is a strong electrolyte and why. So if we look at